Hey guys, today we are talking specifically about parallelograms and the properties that they hold. So first off, we need to define what a parallelogram is. So a parallelogram is going to be a special type of quadrilateral. Quadrilateral is our four-sided figure. So a quadrilateral with both pairs of opposite sides parallel. Quadrilateral with both pairs of opposite sides parallel. So we're going to know some things about the quadrilateral then if we know that both pairs of opposite sides are parallel. We also know that both pairs of opposite sides are congruent. So if we have a parallelogram here, PQRS, then we know that PQ is going to be congruent to RS, and that QR is going to be congruent to SP. We also know then that both pairs of opposite angles are congruent. So we know that angle P will be congruent to angle R. We also know that angle Q will be congruent to angle S. So those angles that are across from each other are going to be equal to each other. We also know something about its consecutive angles, the angles next to each other. We know that they are supplementary. And it doesn't matter which pair of consecutive angles we're talking about. This says x plus y, so this could be this x plus y, or it could be this x plus y, or any of the other combinations, because we know that those angle y's are the same measure. So x plus y equals 180 degrees. Okay, if a quadrilateral is a parallelogram, we also know that its diagonals bisect each other. So QM would be congruent to SM, and PM would be congruent to RM. So knowing all of those properties, here's a type of problem that you might see. We see opposite sides are parallel there, so we know we have a parallelogram. So once we know we have a parallelogram, then we can say, okay, now we know all of these things are true. So we also know that opposite sides are congruent. So since opposite sides are congruent, FG is x plus 6, and HJ is 13, and we can set those equal to each other and we'll solve. So minus 6 on both sides, and x equals 7. So in this case, it's not going to be the algebra that's challenging for you. It's going to be knowing the properties and when you can use them based on the figures. So now we're looking at finding angle y. So y is across from 68 degrees, and we know that opposite angles are congruent. So y is just 68 degrees. All right, let's check out this next example. It says, in a gate as shown, a gate contains several parallelograms. Find the measure of angle ADC when the measure of angle DAB is 65 degrees. Okay, so we know opposite angles are congruent, but consecutive angles, those angles next to each other, are supplementary. So if they're supplementary, then we need to take 65 degrees away from 180. So 180 minus 65 tells us that the measure of angle ADC is 115 degrees. Okay, given that FGHJ is a parallelogram, find MH and FH. So we look at FM and see that it's 5, and we know that in a parallelogram, diagonals bisect each other. So that means that MH would also be 5. And then if MH is 5 and FM is 5, then FH would be a length of 10. By segment addition, we add them together. All right, last example. It says the diagonals of STUV intersect at point W. Find the coordinates of W. Well, we always want to be able to show our work and justify our answers. So I know you probably could count, but let's go ahead and find where that point W is. And so to do that, we're going to find the midpoint, that middle point. Since they bisect each other, it cuts it in half. We want the point on the middle of that segment. So I'm going to do the middle of S to U. If you want to use T and V, you absolutely can. But S is at 0, 0, so that makes things nice. And then U is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 5. Now remember that our midpoint formula is where we add our x values and divide by 2. And then we add our y values and divide by 2. So we add our x values, we get 0 plus 6 over 2. And we get 0 plus 5 over 2. So 0 plus 6, we get a 6 over 2, and 0 plus 5 is 5 over 2. So 6 over 2 gives us 3, and 5 over 2 gives us 2.5. So your midpoint there, point W, is at 2.5. All right. We'll practice more of this in class. If you have questions, please come in and see me. Have a great day.